Hi, boys and girls. This is Mrs. Luckenball. Today we're going to learn about the commutative property of addition. Start out by reviewing some important math words. I say it, you say it. Number one, I say plus sign. You say it. Number two, addends. 3, counting on. 4, sum. 5, addition sentence. Now I am going to give you a clue. If you think the answer is number 1 plus sign, hold up a number 1 on your fingers. If you think the answer is number 2 addends, hold up a number 2 on your fingers. If you think the answer is number 3 counting on, hold up a number 3 on your fingers. If you think the answer is 4 sum, hold up a number 4 on your fingers. And if you think the answer is 5 addition sentence, hold up a number 5 on your fingers. Here we go. The first clue is, which word means the two numbers that are being added? Hold up a 1, 2, 3, 4, or 5 on your fingers to show your answer. The two numbers that are being added in an addition sentence. If you're holding up a number 2, good job. The answer is addends. Addends are the two numbers that are being added in a number sentence. The next clue is the answer or how many there are all together in an addition sentence. 1, 3, 4, or 5. The answer or how many there are all together in an addition sentence. Are you holding up a number 4? If you are, good job. Next, an equation where two addends or numbers are joined together to make a sum. An equation where two addends or numbers are joined together to make a sum. 1, 3, or 5. The answer is 5. That's an addition sentence. Next, this is the strategy where you think the larger addend in your head, and then you count on with the smaller addend to find the sum. 1 or 3. The strategy where you think the larger addend in your head, then you count on with the smaller addend to find the sum. Are you holding up a number 3? That's the counting on strategy. Good job, boys and girls. And last, this is the symbol used to show that two addends are being joined together. The answer is the only one left, of course. That's a plus sign. A plus sign is the symbol that we use to show that two addends are being joined together. Let's review the counting on strategy. Let's look at the picture. I see someone thinking, and then here I see fingers to help me count. So the counting on strategy is where I put the larger addend in my brain, and then I count on using the smaller addend. So let's look at 6 plus 3. Which one is the larger addend? Did you say 6? If you did, that is correct. We would put 6 in our brain, and then we would count on with 3. So we would say 6, 7, 8, 9. And let me show you that here. So we would think 6 and count on 7, 8, 9. Same thing down here on the number line. We would start here on 6 and we would count 7, 8, 9. So the answer or the sum is 9. Okay, the next one is 5 plus 6. Which one is the larger addend, boys and girls? 6 is the larger addend. So let's think 6. Think 6 and count on 5. Ready? 6, 7, 8, 9, 10, 11. And let's look at that down on the number line. 6, 7, 8, 9, 10, 11. The sum is 11. How about 2 plus 4? Which one is the larger addend? 4 is the larger addend. So we would think 4 and count on 2. 4, 5, 6. 4, 5, 6. The sum is 6. And then 7 plus 1. Which is the larger addend? Did you say 7? Good job. We would say 7 and count on 1, which is 7, 8. Let's look at that on the number line. 7 and 1 more is 8. So the sum is 8. This is Michael. Michael has $5 that he got from his grandma. And he's going to spend it on some snacks at the store. And he decided that he is going to buy 2 Snickers bars and 3 Hershey bars. That sounds like a good choice to me. How about to you? His sister Michelle also got money from their grandma, and she bought some snacks too. She bought 3 Hershey bars and 2 Snickers bars. Do you think that Michael and Michelle have the same number of candy bars? How do you know? We're going to come back to this question a little bit later, but we're going to learn today how the commutative property of addition can help us to explain if Michael and Michelle have the same number of candy bars. The commutative property of addition, boys and girls, says that no matter which order the addends are in, the sum stays the same. 7 plus 6 equals 13, and 6 plus 7 still equals what? 13. Just because we flip-flop the addends doesn't mean that the sum will change. The commutative property of addition has the word commute in it. Do you hear that? Commutative. Commute. The word commute means to move. So if we think of the addends moving, that will help us remember that big word, the commutative property of addition. 4 stars plus 2 smiles equals how much altogether? 6 altogether. Good job. The commutative property of addition says that I can flip-flop the addends 4 and 2, and it will still equal what? You're right. It will still equal 6. These are called related facts. Think back to first grade. Do you remember the part-whole chart? What are the 2 little parts that are joined together, boys and girls? The 2 little parts that are joined together are the 4 and the 2. And down here, it's the 2 and the 4. So those little parts go in the little boxes because they are the parts. And I can write the 2 or the 4 in either box. It doesn't matter. Now the big box at the top is where we write the whole. That's how much is joined together when we put 2 and 4 together to make 6. These are related facts because they're part of the same family. Now it's time, boys and girls, for you to get out a marker board or a piece of paper. I'm going to show you an addition fact, and I'd like you to write the related addition fact using the commutative property of addition. So on the screen, you see 8 plus 1 equals 9. And when we think about our part-whole chart, we know where those numbers go. What are the two small parts that are being added together? 8 and 1. And what is the whole? After we put 8 and 1 together, we get 9. I'd like for you on your marker board or your piece of paper to flip-flop those add-ins and write the related addition fact. Pause the video until you're done. Okay, let's take a look. How did you do? Did you flip-flop the 1 and move it here and put the 8 over here this time? If you did, you used the commutative property of addition. What is the sum? Do you think the sum is still 9? And the answer is yes, the sum is still 9. It doesn't matter if I say 8 plus 1 or 1 plus 8. The sum is still 9. These two addition sentences are related. Let's try another one on your marker board or your piece of paper. This time, the parts are 5 plus 3, but I'd like you to figure out the sum. Let's think about our part-whole chart for a minute. 5 plus 3. 5 and 3 are my parts. Your job is to write a related addition sentence and figure out the sum. Pause this video until you're done. Did you write 3 plus 5? Did you flip-flop the add-ins? Good job. Now, what is 5 plus 3? I know from the counting on strategy that I'm going to put 5 in my head and count on 3. Ready? 5, 6, 7, 8. The sum is 8. Do you think the sum is 8 when I flip-flop the add-ins? Let's try it. Let's say 3 and count on 5. 3, 4, 5, 6, 7, 8. Yes, the sum is still 8. And I can put that here in the whole part of my part-whole chart. Board or paper ready again for this one. 1 plus 3. I would like for you to draw the part-whole chart on your paper. And then I'd like for you to put the parts in the chart. Pause this video until you're done. Did you put 3 and 1 as the parts? Good job. Now I'd like for you to write a related addition fact. Pause this video until you're done. Did you flip-flop the add-ins and write 3 plus 1? What is 1 plus 3, boys and girls? Did you write 4? Do you think that 3 plus 1 is still 4? Yes. The sum stays the same, even when we flip-flop the addends. So the whole is 4. This time, I gave you some different numbers. Do you notice what's missing? Do you see that one of the addends is missing? Draw a part-part whole chart on your paper. Can you figure out where the 3 and the 7 go in your whole part-part chart? Pause this video until you're done. Did you remember that 7 is the sum, and the sum is the whole, and it goes up here? 3 is one of the addends. It's one of the parts. We don't know what the other part is. So this is a little different, isn't it, boys and girls? How can we figure out the other part? Talk about that with your partner or your teacher. One thing we could do is start at 3 and count up to 7 and see how many that is. Are you ready? 3, 4, 5, 6, 7. How many is it from 3 to 7? 4. Good. There are other strategies you could have used. You could have started at 7 and counted back to 3. Or you could have taken 3 away from 7 and found out that there was 4. So there's quite a few strategies that you could have used to figure that out. Now that we know that the missing addend is 4, now I'd like you to write a related addition fact. Did you write 3 plus 4 equals 7? Boys and girls, there's missing numbers here. All we have is which part? We have the sum, don't we? But we're missing the addends. Let's think about what we know. We know that the sum is the whole, so I can put what I know here in my chart. Your job is to think of what 2 parts might make 4. And guess what? There's more than one correct answer. So I would like for you to take some time on your marker board or paper to figure out what 2 parts could make 4. Share that with your partner or your teacher and talk about all the different ways that you could make 4. Pause this video until you're done. Here's Michael, boys and girls, and here's Michelle again. Let's think about what we've learned about the commutative property of addition. Do Michael and Michelle have the same number of candy bars? How do you know that? How does the commutative property of addition help us figure out or explain how we know that they have the same number of candy bars? We know that Michael has 2 Snickers bars and 3 Hershey bars, and we know that he has 5 altogether. Michelle has 3 Hershey bars and 2 Snickers bars, and she has 5 altogether. The commutative property of addition helps us know that because all we did was flip-flop the addends. and the sum stayed the same. Michael and Michelle both still have 5 candy bars.